Good day, students. Now continue our video lessons, and it is the 8th lesson, and the name of new topic is the normal distribution. The normal distribution. Normal distribution. Normal distribution. Normal distribution. Its distributive density has the following form: f little of x is 1 over sigma multiplied by 2 pi integral from minus I'm sorry, they are not there is an integral multiplied by e raised to minus x minus a squared over 2 sigma squared. It is the normal distributive density. Normal distributive density. Normal distributive density. Normal distributive density. Here x is variable and a and sigma are the parameters. A and sigma are the parameters. A and sigma. A and sigma are the constant values, and are the characteristics of the normal distribution. First, consider the properties and the graph of the normal distributive density. Write properties. First property. This function at infinity tends to the 0. Limit f of x when x tends to infinity, plus or minus infinity, in general to infinity, equals limit when x tends to infinity of 1 over sigma square root of 2 pi multiply e raised to minus x minus a squared over 2 sigma squared equals 1 over sigma square multiplied by square root of 2 pi is a constant factor, and it is taken out of the limit symbol. 1 over sigma square root of 2 pi multiplied by limit when x tends to infinity of e raised to minus x minus a squared over 2 sigma squared. Then rewrite expression on the limit expression in the following form: 1 over sigma multiplied by square root of 2 pi equals limit when x tends to infinity 1 over e raised to x minus a squared over 2 sigma squared. Here x tends to infinity, substitute infinity instead of x here. Infinity plus or minus infinity minus a is also plus or minus infinity because a is constant, and plus or minus infinity raised to squared is only plus infinity. Plus infinity divided by plus positive number is again plus infinity. E raised to plus infinity is also plus infinity, and finally 1 over plus infinity is 0. That is 0. It means at infinity our function tends to 0. Limit f of x when x tends to infinity is 0, and it means the horizontal line y equals 0 is the horizontal asymptote, and it is also x-axis. It is first result of the first property. Now go to the second property, and according to this property, the normal distributive density is a symmetric function, and its symmetry point or symmetry center is the parameter a. And for this we must prove the verification of the indication or the definition of the symmetry function for the normal distributive density. First, obtain an expression for the f of a minus x. And substitute a minus x instead of x. And here substitute a minus x instead of x here in this expression. 1 over sigma multiplied by 2 pi multiplied by e raised to minus a minus x minus a squared over 2 sigma squared equals 1 over sigma multiplied by 2 pi multiplied by e. Here a and minus a are removed, and then we have only minus x squared is simply x squared, and we obtain minus x squared over 2 sigma squared. Then obtain the expression for f of a plus x equals for this we must substitute a plus x instead of x here. 1 over sigma multiplied by 2 pi multiplied by e raised to minus a plus x minus a squared over 2 sigma squared. Here a and minus a will be removed, and then we will have only x squared, and it is equal to 1 over sigma multiplied by square root of 2 pi multiplied by e raised to minus x squared over 2 sigma squared. Already we see that f of a minus x is equal to f of a plus x. F of a minus x, because their right parts are the same. It is equal to f of a plus x. But it is indication of the symmetric function. It means the normal distributive function is the symmetric one, and its symmetry center is a. Now a is symmetry center. A is the symmetry center. center. Then go to the third property. Then go to the third property, and in this property we will show that the mode of the normal distributive density is also the parameter A. What is mode? Mode is such a point at which the function the distributive density has the graded value or maximal value. For finding the extrema of this function, we must equalize the derivative of this function to 0. First find the derivative of this function. f prime of x equals 1 over sigma multiplied by square root of 2 pi multiplied by e raised to minus x minus a squared over 2 sigma squared prime. And here the constant factor, the coefficient of 1 over sigma multiplied by square root of 2 pi is the constant factor, and it can be taken out of the derivative symbol. 1 over sigma multiplied by square root of 2 pi e raised to minus x minus a squared over 2 sigma squared prime. Then it is the composite function, and it can be represented as e raised to u. E to u prime is e to u multiplied by u prime. That is equals 1 over sigma multiplied by square root of 2 pi multiplied by exponential function itself and multiplied by the derivative of its exponent, e to minus x minus a squared over 2 sigma squared multiplied by the derivative of this expression, minus x minus a squared over 2 sigma squared prime. Then further we can take minus 1 over 2 sigma squared out of the derivative symbol. 1 over sigma multiplied by square root of 2 pi multiplied by e raised to minus x minus a squared over 2 sigma squared multiplied by minus 1 over 2 sigma squared multiplied by x minus a squared prime. X minus a squared is also the composite function. It is can be represented as a t squared. T squared prime is 2 multiplied by t and multiplied by t prime. Therefore, it is 1 over sigma square root of 2 pi multiplied by e raised to minus x minus a squared over 2 sigma squared multiplied by minus 1 over 2 sigma squared and multiplied by 2x minus a multiplied by minus x minus a prime. And x minus a prime is simply unit. And finally, and here 2 and 2 can be simplified. And finally, we have that f prime of f of x is equal to 1 over sigma multiplied by square root of 2 pi multiplied by e to minus x minus a squared over 2 sigma squared, then multiplied by it is unit multiplied by minus 1 over sigma squared multiplied by x minus a. It is the expression of the derivative of the normal distributive density. Further equalize the derivative to 0 and then find the critical points, possible critical points. If f prime of x is 0, then the expression also is equal to 0, and we have that minus of x minus a also is 0. 1 over sigma multiplied by to square root of 2 pi multiplied by e raised to minus x minus a squared over 2 sigma squared multiplied by minus x minus a divided by sigma squared is equal to 0. Here 1 over sigma multiplied by square root of 2 pi and sigma squared, 1 over sigma squared are the constant values, and exponential function has only the positive values. Therefore, only the expression minus x minus a can be equal to 0. Therefore, minus x minus a is 0, then x minus x is equal to 0. It is the critical point. We have only one critical point, and it is a. Then construct the real axis and mark the point A in this axis, on this axis A, from minus infinity to plus infinity, and we obtain two intervals from minus infinity to A and from from A to plus infinity. If x is greater than a, that is, if x is situated on the right of the point A, then x minus a is positive, and minus x minus a is negative. If this is negative, then the first derivative is also negative. F prime of x is negative. That is, the derivative of the normal distributive density in the right interval has the negative sign. But if x is less than a, it means the point x, the variable point x, is situated on the left of the point A, then x minus a is less than 0, and minus x minus a is positive, and it means the derivative itself is positive. In the first interval, our derivative is positive. And according to the sufficient conditions of the extremum existence, if in the passing through the critical point from the left to the right, the sign of derivative is changed from plus to minus, It means that the given critical point is the maximum point. It is maximum point. If A is the maximum point, it means that point A is the mode. A is the mode. A is the mode. Is mode. 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 And then find the value of f of x at the point A in the mode. If substitute A instead of x, we will obtain A minus A is 0, e raised to 0 is 1, and we will have only only the coefficient 1 over sigma multiplied by square root of 2 pi. And the f maximum value, or the greatest value, is 1 over sigma square root of 2 pi. Then construct the graph of the normal distributive density itself. Finally, construct the graph of the normal distributive density. Normal distributive density. Y 0 x minus infinity plus infinity, and mark the point A on the x-axis, A, and the corresponding value of function is 1 over sigma square root of 2 pi. And then construct the graph itself. It is the graph of the normal distributive density. F of x is equal to 1 over sigma square root of 2 pi multiplied by e raised to minus x minus a squared over 2 sigma squared. Already you know that A is symmetry center, and also A is mode. Symmetry center, and also the mode. Then we will prove that the A is also the mathematical expectation, or the expected value, and also already you know that if the f of x is the given function, f of x is the symmetry function, then this function, the symmetry center, is also the median, and it is also median. Then we will prove that it is also the mathematical expectation. Now verify the properties of the normal distributive density. According to the first property, at the infinity the function f of x tends to 0, and the x-axis is the horizontal asymptote, and its equation is y equals 0. According to the second property, it is the symmetry function, and its symmetry center is A, and you see that the branches of this graph is symmetric with respect to the vertical line x equals A. And according to the third property, this point is mode, A is mode, and it means at the point A our function has the greatest value or the maximal value, and its value is equal to 1 over sigma multiplied by square root of 2 pi. Then verify the basic probabilistic equality for the normal distributive function. Write the name of the topic, the verification of the basic probabilistic equality for the normal distributive density. Normal distributive density. It is the topic of the next. It is the name of the next topic. Already we have the expression of the normal distributive function. It is normal distributive function. Normal distributive function. And remember the basic probabilistic equality. Integral from minus infinity to plus infinity, f of x dx is unit. For the proving of this formula, we must use the known fact from the calculus. According to this fact, integral from minus infinity to plus infinity of e raised to minus t squared dt is square root of pi. This is the interesting fact from the calculus. And now we can separate this integral into two integrals from minus infinity to 0 plus integral from 0 to plus infinity. Integral from minus infinity to 0 of e raised to minus t squared dt plus integral from 0 to plus infinity of e to minus t squared dt is square root of pi. And you must know that this function e raised to minus t squared has no the antiderivative, has no the finite antiderivative, and it is this fact was proved with the help of the functional series. Then here change here make the now here make the change in the first integral and change t by minus z. Let in the first integral let t change. Let t is minus z. then dt is minus dz, dt is minus dz, and here we must also here we must change the integral limits. The given integral limits are real for the variable t, but for z the integral limits will be other values. If t is minus infinity, t is minus infinity, and if substitute the minus infinity instead of t, the z is plus infinity. Z is plus infinity. And if t is 0, then z is also 0. Then continue. Then continue. Rewrite the first integral with respect to the new variable t, new variable z. I'm sorry, variable z. Integral from plus infinity to 0 of e raised to minus z squared minus dz multiplied by minus dz plus integral. Second integral is retained. Integral from 0 to plus infinity of e raised to minus t squared dt equals square root of pi. Then here minus z squared is simply z squared, and the negative sign can be taken out of the integral symbol. Minus integral from plus infinity to 0 of e raised to minus z squared dz plus integral from 0 to plus infinity of e raised to minus t squared dt is square root of pi. Then change the places of the integral limit in the first integral, and you know that if change the place of integral limit, then this integral will change own sign, and therefore we will obtain positive sign. Plus integral from 0 to plus infinity of e raised to z squared dz plus integral from 0 to plus infinity of e raised to minus t squared dt is square root of pi. Then continue. Also, you know that the value of the different integral doesn't depend on the integral variable, and therefore we can change that by t. Integral from 0 to plus infinity e raised to minus t squared dt plus integral from 0 to plus infinity of e raised to minus t squared dt is square root of pi. We have the same integrals, and it is twice integral from 0 to plus infinity of e raised to minus t squared dt is square root of pi. And finally we have the new formula, integral from 0 to plus infinity of e to minus t squared dt is square root of pi in half. This first formula, and therefore we will obtain and other formula, and already we proved that this integral is equal to this integral, and this integral is also equal to this value, and integral from minus infinity to 0, I'm sorry, from minus infinity to 0, from minus infinity to 0 of e raised to minus t squared dt is square root of pi in half. These formulas will be used in future. Then continue, and now verify the basic probabilistic equality for the normal distributive density. Here substitute the expression of f of x into this integral. Integral from minus infinity to plus infinity, 1 over sigma square root of 2 pi 1 by e raised to minus x minus a squared over 2 sigma squared dt. Here the coefficient 1 over sigma square root of 2 pi can be taken out of the integral symbol. Then 1 over sigma multiplied square root of 2 pi, integral from minus infinity to plus infinity, e raised to x minus a squared over 2 sigma squared dt. I'm sorry, here dx, right dx, I'm sorry, dx. Then make the following change. Let x minus a over sigma square root of 2 is t. Then x minus a squared over 2 sigma squared is t squared. Then find the x from here. X is equal to a plus sigma square root of 2 multiplied by t, and then find dx itself. Dx is sigma square root of 2 dt, because the differential of a is 0, and you know that the differential, the derivative and also the differential of the constant value is simply 0. Then check the integral limits for the new variable t. If x is minus t, substitute minus infinity instead of x. Minus infinity minus a is minus infinity. Minus infinity divided by a positive number is also minus infinity. T is minus infinity. And then if x is plus infinity, then t, if substitute plus infinity instead of x, then we will have that plus infinity minus a is plus infinity. Plus infinity divided by positive number is also plus infinity. T is also plus infinity. And consider and use this change in the last integral. 1 over sigma square root of 2 pi multiplied the integral from minus infinity to plus infinity of e raised to minus t squared multiplied dx sigma square root of 2 dt. Here sigma square root of 2 is the constant factor, and it is taken out of the integral sign. Then we have 1 over 1 sigma square root of 2 pi multiplied by sigma square root of 2 multiplied by integral from minus infinity to plus infinity e raised to minus t squared dt. Here we can simplify by sigma and square root of 2. And here in the front of integral we have only 1 over square root of pi. Pi multiplied by integral from minus infinity to plus infinity of e to minus t squared dt. But already you know that this integral is the known integral from calculus, and it is square root of pi. Square root of pi. And then we obtain 1 over square root of pi multiplied by square root of pi is simply unit. Already we verified the basic probabilistic equality for the normal distributive density. Thank you for your attention. Our lesson ended. Good luck. Goodbye, students.